So raise the coefficient to the outer exponent. Okay, the power rule, then you're going to use the power rule to simplify the exponent. So, the example to this, if I have a to the m power, all raised to the n power, I multiply my two powers together. A to the m times n. So in the first example, I have x to the 2 times 5. I multiply the powers. That's x to the 10th. Okay, here I must distribute, write distribute. I distribute that 3. What power is the c to? No. 1. C is to the first power. 1 times 3 is 3. D is to the second. 2 times 3 is 6. Okay, so number 3 and 4 is a big example. They look very different from the point that the coefficient is outside of the parenthesis. Coefficient is inside. -4 is not being cubed here. It's just out front. It's -4 times m to the first and n to the fourth. I have to multiply the powers. 1 times 3 is 3. 4 times 3 is 12. This one's different. 2 is inside the parentheses. 2 is being raised to the first power right now. 1 times 5 is 5. I have 2 to the 5th power. X squared. 2 times 5 is 10. Y to the first power. 1 times 5 is 5. Now I need to simplify 2 to the 5th. 2 to the 5th power is 32. X to the 10. Y to the 5th. Okay, now I have -3 to the first power, x to the second. All raised to the third. Now, -3 times -3 times -3 is -27. So -3 to the third power is -27. X to the second power times 3. X to the 6th. I need to take care of the coefficients, then take care of the variables. Next one. I have 1/2 cubed. That's the same as writing this. 1/2 times 1/2 times 1/2. When I multiply fractions, you multiply the top numbers. 1. Multiply the bottom. 8. 1/8. Distribute 3 times 3 is a to the 9th. 3 times 4, b to the 12th. 3 times 5, c to the 15th. Okay, let's skip down to number 9. Okay, number 9, I have two different monomials going on. One here and one here. I need to take care of the left one first. You can kind of see this already written in PEMDAS. Parentheses, exponents, multiplying, dividing, adding, subtracting. I need to take care of this part first, the parentheses and the exponent. 3 times 3 is x to the 9th. 3 times 3, y to the 9th, times xy squared. What rule do I need to use now because of this?
Addition.
Not the addition. What's happening right there? It's multiplying. So I must use the product rule, which states that I add the exponents. So x to the 1st and x to the 9th becomes x to the 10th, y to the 9th and y to the 2nd to the 11th. So I'm kind of combining both rules now in the same problem. Let's try number 10. A squared and a to the 4th. Multiply them, that's a to the 8th. B to the 1st times 4, b to the 4th. Now I must use the product rule. Product rule states that I add the exponents. Okay, number 13. I have to apply the cubed to the 2. This is 2 to the 1st power. 2 to the 3rd power is 8. 2 times 3 is 6. Product rule, I add them. 2 plus 4 is 6. Now I have the same variable to the same power twice. These are like terms. I can add these together. The power in the variable stays the same. Only the coefficients change. 8 plus 3 is 11. Somebody said number 12?
Yes.
Distribute the 3. 6 to the 3rd power.
216.
Oh, 216.
Yeah.
3 times 2, a to the 6th. Don't forget that's b to the 1st. 3 times 1, b cubed. 1/3. That's the same as 1/3 times 1/3, which is 1/9. A squared, b squared, c squared. These are all to the 1st power. I must multiply the power to everything inside. Now, I add the powers. Can somebody do 216 divided by 9? 24. Add the powers. 6 plus 2 is 8. 3 plus 2 is 5. And there's no c here, correct? On the left side? No, so I just keep this. C squared. There's nothing to add the power to.